This video is on exponents, the rules for exponents, and how we work with exponents. It's important to note that exponents are simply a notation for repeated multiplication. So for instance, 3 squared means 3 times 3. 3 cubed means 3 times 3 times 3. Therefore, 3 squared equals 9, and 3 cubed equals 27. A common confusion is to think that it's 3 times 2 is 3 squared, but it's not. It's 3 times 3. Or that 3 cubed is 3 times 3. It's not. It's 3 times 3 times 3. So it's multiplication repeated that many times. An important rule of exponents is this multiplication rule. And the multiplication rule says essentially, if you have two terms with the same base and you multiply them together, the only thing you have to do is add their exponents. So in the case of x to the 5th power times x to the 6th power, it's x to the 11th power. It's important to note that this is happening only with multiplication, okay, not with addition or subtraction. So it only works when you're multiplying the numbers, not when you're adding or subtracting them. Notice too that you keep the same base, and notice that when you do the multiplication, if there are coefficients, you also multiply the coefficients. So in the case of 4x squared times 3x to the 4th, you do 4 times 3, which is 12, but you do 2 plus 4, which is 6. So we get 12x to the 6th. Division, as we know, is closely related to multiplication. So with a lot of similarity but only a few changes, we can do similar things. For instance, if we have a to the m power divided by a to the n power, that's the same as saying a to the m minus n. In other words, when you're dividing two numbers with the same base and exponents, you can subtract the exponents. For instance, in x to the 11th power divided by x to the 9th, that's the same as x to the 11 minus 9th power, or x to the 2nd power. Another way of looking at this would be to think about this as if you had x to the 3rd power and you were dividing by x squared, you could write this out as x times x times x over x times x. And look, you can cross out one on top, one on the bottom, another one on top, another one on the bottom, leaving you with just x. Or if you thought about it as 3 minus 2, you'd be left with 1. So it works out the same way, it's just two different ways of thinking about it. Likewise, if there's a coefficient, in this case, you just divide the coefficients. 8 divided by 2 is 4. Here, if you're multiplying two numbers and then raising them both to the same power, you can actually distribute that power. So if you have some multiplication going on, a times b, and that whole multiplication is raised to the m power, that's the same as a to the m power times b to the m power. In our example here, 3x squared to the 3rd power, we would distribute this 3 to both of the terms, 3 to the 3rd power and x squared to the 3rd power, or x to the 6th power, which would be 27x to the 6th power. We saw in the previous slide that we had x squared raised to the 3rd power, and what we did there was multiplication. So that brings us to our next rule, which is the power to power rule. If we have some base a raised to the m power, and that whole term is raised to the n power, we can rewrite that as a to the m times n power. So x to the 5th power times, or x to the 5th power raised to the 6th power means x to the 30th power. So when we're doing a power of a power, meaning we're raising a whole power to an additional power, it's just multiplication at that point. The 0 power rule simply says anything raised to the 0th power is 1. If that thing is negative, we can say that that is negative 1. So in the case of 25 to the 0th power, that's 1, or even 2xy to the 0th power, that's 2x times 1, or 2x. Or if you have 35xyz, it doesn't matter, and you have parentheses and you raise that all to the 0th power, that's still 1. Now for the negative power rule. Have you ever wondered what happens when you're raising something to a negative power? Well, essentially you're creating a fraction. Okay, that's an easy way of thinking about it. So a to the negative nth power equals 1 over a to the nth power. And I know that looks a little off kilter there in terms of its alignment. But essentially the way you want to think about this is, see how we have 4 to the negative 3rd power? Well, that's the same as 1 over 4 to the 3rd power. Okay? Or another example would be 3 to the negative 2nd power. That's the same as 1 over 3 to the second power. See how I am finding the reciprocal and then making my power positive, which again simplifies to 1/9. Okay. Here is the opposite happening, right? I have 1/5 to the negative second power. I find the reciprocal, 5, and I raise it to the positive power of 2. So you can sort of think about negative powers as causing reciprocals. They do not cause negative numbers. That's a common confusion. Negative exponents do not cause negative powers.